Hello students of Year 11 Maths General, and welcome to exercise 4K, which is about solving simultaneous equations graphically. Now before we take a look at this method, we just need to consider a few facts about simultaneous equations and their graphs. So the first of these is that when we solve simultaneous equations, we're finding the value of x and the value of y that will make both equations true. Now obviously if your simultaneous equations aren't using x and y, they're using other letters like a and b, that same statement holds just for the letters a and b instead. Another way of saying what I've just said, though, is we are finding the point where x is the same in both equations and where y is the same in both equations. And since we know that equations describe graphs, finding this point where both x and y are the same in both graphs means that we're finding the point of intersection of those two graphs. So if they describe straight lines, we're finding the point where those two straight lines intersect. And that's primarily what we're working with in Year 11 General, is straight line graphs. So that means if we simultaneously solve two straight line equations, we're finding the point where they intersect. Now there's actually two implications to this piece of information, which we'll look at now. So the first is that we can solve simultaneously to find where two equations intersect. So if you're given two straight line equations, you could find out the intersection point just by solving simultaneously with the substitution or the elimination method. The second implication is that instead, if we could graph, to find the solution to a pair of simultaneous equations. So if I'm given two simultaneous equations, I could graph those either on a piece of paper on a grid or on my computer with Desmos graphing calculator, for example, and that would give me the solution to the pair of simultaneous equations. And that's the focus of this screencast. So we'll take a look at an example now. Now, this says when simultaneous equations are graphed, the coordinates of the point of intersection gives us the simultaneous solution. That's the fact that I just told you. So let's take a look at an example here. I've got y plus 2x equals 5. So if I just Alt-Tab to Desmos, I can type in y plus 2x equals 5. Now, because this equation could be rearranged to be of the form y equals mx plus c, Desmos is interpreting that for me without having to do the transformations myself, and it's turned it into this straight line. So that's the graph of y plus 2x equals 5. Now, what I want to do, though, is I want to find out where does this equation intersect the second equation here. So 3x take 2y equals 4. So let's type that in now as well. 3x take 2y equals 4. And here we go. So that's created a straight line equation as well, because just like the other equation, this has x and y in it, and they're both just non-squared terms. They don't have any power other than 1. So that means I could rearrange this to say y equals mx plus c with some gradient and some y-intercept. Now, because we've graphed this, we can now zoom in a little bit and take a look. Where do these two lines intersect? And where they intersect is at the point 2, 1. So what that means for us, if we go back to our slideshow here, is they intersect at the point 2, 1 there. So therefore, x equals 2 and y equals 1 is the simultaneous solution for those two graphs, or for those two equations. Now, when you're doing these textbook questions in exercise 4K, you're welcome to use Desmos to answer every single question. However, you should definitely keep in mind that in an exam situation, you don't have access to Desmos.